Masoud is going to join us on the stage any minute, and he from his research lab, they've set up recently a company, NanoPrintek, and they are launching a dry multi-material printer that can do inkless printing. So, hi Masoud, good to see you
Hello,
again.
good seeing you. Thank you so much.
Yeah, you're good to go. So good luck. You have 15 minutes.
All right, thank you so much for inviting me, Kasha. I really enjoyed so far this beautiful platform that we have created. I appreciate it. Well, yes, my name is Masoud Mahjouri-Samani, and I'm a president and the founder of NanoPrintek, which we have started a few months ago. And today I'm going to just explain what we do and what we manufacture in the NanoPrintek. Basically, we are manufacturing the dry multi-material printer, which is an inkless technology with on-demand generation and real-time sintering of pure nanoparticles. Now, the motivation comes from the move, of course, toward the Industry 4.0 and especially the Internet of Things, where every object is intended to be smart. Of course, you need technologies to integrate those smartness into objects. So the objects can collect data, process data, communicate data with a large network of other objects. But how can we go there? That is the question. Well, the printed electronics or additively manufactured electronics or the solutions so far, it seems, that can integrate various parts and objects into these platforms. But what you need eventually is a technology that can integrate various different types of functional materials and structures onto different objects with different shapes and orientations, such as capacitor, batteries, solar cells, displays, sensors, antennas, and you can see that all these things require different materials and different integration processes. So the current technology, as you have heard so far, you can see that, well, almost most of them are based on ink. And when you are dealing with ink, you should integrate multiple industries basically together to make sure that this technology works. For example, a nanopowder manufacturing industry has to make the right nanopowder, which is quite expensive, quite challenging process. And then it goes to the ink manufacturing industries to make right inks with the right viscosities and loadings for different machines. And you can see that how complex and expensive that process is, as we have gone through many presentations so far. And because of that complexity, it's quite hard to make any kind of inks that we want. That's why we have limited printing material options to date. And then those inkjet or aerosol jet or other printers, they take those inks, they print your electronics, and then it have to eventually do the sintering process, remove the contamination and all those ink associated contaminations that we have added to the ink to make the printed lines basically electrically reliable and viable. And finally, you have to go through this process of post processing to make sure everything is right, so you can eventually have your printed electronics. Now, what we do at NanoPrinting is that our technology integrates all these different industries into one machine. Basically, all you need is to have a solid target of your material of interest. This solid target goes inside the printer. The printer will generate nanoparticles in real time and on demand. These nanoparticles then will flow out of the nozzle, and another laser comes and in real time sinters these nanoparticles together to form your printed electronics. Therefore, this gives you flexibility of choosing any material. You can do multi-material, you can do metals, ceramics, semiconductors, and so on and so forth. So as you can see, this technology does not need ink. There is no post-processing involved. There is no ink-associated contaminations. It is extremely eco-friendly, and also it is multi-material and cost-effective process. Now here is an example. Now let's say you have silver or other targets inside your printer. A laser comes and creates nanoparticles. If the ablation laser is on and the sintering laser is off, you can generate these nanoparticles, which are mostly amorphous or metastable phases of nanoparticles, which is about 3 to 5 nanometers usually.